Okay, so you had a lot of time to try this on your own, but I didn't feel like you were really doing kind of stuff productively. So let's try it for the small cases, okay? So here we have n numbers, right? And you have like funny letters representing them. Well, wouldn't it be simple if there was only one number? Yeah? Yeah? And there's only one number, you see? And then it only takes one step to switch to that one number, right? So then this is always an arithmetic progression, you see? Does that make sense? So the question is, what's the smallest difference you can make it? You know? What's the smallest difference you can make between A and B? Leadership Lucas?
Yeah.
What's the smallest difference you can make with A and B?
Well, if it's positive integers, then it should be 1, right?
Yeah, exactly. So you can pick any A and B you want, right? Does that make sense? But you know the B has to be bigger than the A, and whatever it's bigger by is the common difference. Does that make sense? So when there's only n is 1, okay, then the difference is 1, you see?
Yeah.
You can't get any lower than 1, right? Because it has to be a whole number, and 0 can't be. 0 means it's not strictly increasing, you see? That's pretty simple, right? None of you did that, yes? So this is the kind of thing I'm looking for. So
I did that.
did you? Did you get 1?
But if n equals 3, then this is what happens. Plus 1.
You didn't get it, okay? So basically, it's not about like doing something impossible. It's about doing things that you know how to do. You know what I'm saying? Okay, so what about 2? What about if n equals 2, yeah? And there's two numbers now, so a1 and a2, yeah? And it has to end up as b1 and b2. You see that? Okay. And it has to switch to b1, a2 in between. So there's 3 numbers now, and they have to have a same gap. Does that make sense? So what do we do here? So I think you just try to come up with some numbers, right? So what kind of numbers? Just name 2 numbers, any 2 numbers. Yeah? You name the numbers.
1 and 3.
1 and 3. Okay, I don't know why you skipped 2, but 1 and 3. And then name another 2 numbers.
7 and 6.
Yeah, see,
5 and 8.
these are not good choices for numbers, okay? So if you get to choose the numbers, why not choose easy numbers for yourself, yeah? So 1 and 3 need to change to 6 and 7, right? So the 1 changes to a 6 first, and then the 3 changes to a 7, see? Okay, so here the number is equal to 3, this is equal to 18, this is 42, okay? So this is not an arithmetic progression, yeah? Does that make sense? Okay, maybe we can do it a bit. Okay, let's start with the number. Let's start with some easier numbers. Why don't you choose 1 and 2, yeah? Okay, and then B, well, whatever the next number is, it's going to have a 2 there, right? You see? So what can you make B? So if you try to make the common difference small, like the common difference here, this is 2, right? This is something times 2. So what's like the smallest difference you can make it? So you make this 2, and this is 4, right? So this has to be 6, yeah? So So this has to be 3, right? So that means you can achieve a common difference of 2, right? Okay. So now the question is, can you achieve a common difference of 1? So we got a common difference of 2. How do you get a common difference of 1? Where's 1 and 3? So you can see whatever number. Okay, so can you try to explain why you can't get a common difference of 1, or if you can, yeah? So the answer has to be 2 or 1, yeah? Michelle, focus on this. Do this. I'll give you 1 more minute to figure out if it can be 1 or not. Okay, so look, whatever number you put as these two numbers, right? This number is always going to be the same as this number, right? This is the A2, A2. Does that make sense? So that number, if it's 2, right, then this has to go up by 2 at least. Does that make sense? So if you wanted to go up by 1, yeah, then this number has to be 1. Does that make sense? Yes? Because if it's 3, it'll have to go up by 3. You understand? Make sense? So you have to make that number a 1, and that has to be a 1, right? Does that make sense? And can you see, for the same reason, these two numbers have to also be 1. Because they're the same, right? So it has to go up by at least that amount. Yeah? Okay. So now what's wrong with this picture? What?
Can you have 0?
You can't have 0.
Yes, it's like, since the first one has to change, it needs to have to stay on 1 for like
Yeah, so the
from 0
first
to
one,
1.
so this one's 1, right? And if it has to start from somewhere, it has to start at 0 and end at 2, right? But you're not allowed to start at 0. Okay, so the answer is 2. Does that make sense? Okay, so here, let's do 3 numbers. So A1, A2, A3, yeah. And it changes all the way to B1, B2, B3, right? You have B1, A2, A3, B1, B2, A3. So now there's 4 numbers with 3 different gaps. And the gaps have to be the same, yeah?
Okay.
Okay, so there's 2 approaches you can take, right? So we can try to get numbers that work, right? Think of 3 numbers.
1, 2, and 3.
Yeah, see, I like that. See, because 1, 2, and 3 are the easiest numbers you can think of, right? What else?
4, 5, and 6.
4, 5, and 6. Well, okay, sure, but like making it harder for yourself.
How about 2, 3, and 4?
Yeah, maybe 2, 3, and 4 is simpler, right?
3, 4, 5.
We do 2, 3, and 4, yeah? So here we have 2, 2, 3, 3, 3, 2, 3, 3, right? That makes sense? This is 2, 3, 3. Yeah? Does that make sense? Okay, so what is this equal to?
6.
What's this equal to?
It's 12. 18. 24.
24, see? So we found something where the common difference is 6, right? So the answer has to be 6 or lower, right? That makes sense? So now the question is, why can't it be lower than 6? Yeah? Why can't it be lower than 6? Okay, so so we got that the difference can be 6, right? And we want to know why it can't be any smaller, right? And there's nothing wrong with just going through the ones one by one. Like, can it be 1? Can it be 2? Can it be 3? Can it be 4? Can it be 5? Yeah. Yeah. So, for example, if it's 5, right? Then like A3 or A2 or B1, all of these numbers, they have to either be 5 or 1, right? They can't be any other numbers because they have to divide the difference. Does that make sense? Okay, but if A3 is 5, if this is 5, right? Say that's 5, yeah? Then all of these other numbers have to be, so like these have to be 1 now, yeah? And this has to, okay, and then B1 has to be 1 more than A1. Okay, and then, but now the problem is B1 is it's more than 1 and it's not 5, right? So then B1 is timesing the difference. So that's not going to work, okay? So you can go through all of this, and we have, okay, but there's some other interesting things we can notice as well, okay? So can you notice, so this is where I need you to pay attention here. So if we look at this, yeah, what do you notice about that? What?
They're all A3s and B3s. They look like n equals 2.
This looks like the n equals 2 case, you see? That makes sense? And we know something about the n equals 2 case. We know that this difference has to be at least 2, right? That makes sense? And so this has to be a common difference because the whole difference is this difference times by the A3, right? Yeah? Does that make sense? You're kind of ignoring me, Max. So the whole difference is this times by A3. So if you divide all the same difference by A3, you're going to get the same difference here. Okay? So that already tells you the difference has to be has to be at least 2 times something, right? So if A3 is like 2, right? And this is like 3, then it's going to be at least 6. See? So this is at least 2 times something. So the answer can't be 1 and it can't be 2. Or it could be 2. But if it's 2, then A3 has to equal 1, right? Does that make sense? So if A3 equals 1, and then that's 2, yeah? Yeah? Then it's going to be very difficult to finish that off. You understand? So there's not very many possibilities. So this thing, it's at least 2, right? It can't be 1. Okay. So if it's like, it can't be 4. Like if it's 4, see the A3 times is by 4, right? So there's nothing that 4 can times to be under. So then A3 would have to be 1, right? So if A1, A2, if these differences is like 3, 4, or 5, right? Then this has to be 1, yeah? That makes sense? The only case when this might not be 1, okay. Oh, sorry, this could be, if it's 4 or 5, it has to be 1. But it could be, if it's 2 or 3, then A3 could be 3 or 2. Yeah? Okay. But the problem is 3 times 2 is still 6. So if you want to get lower than 6, you can't take 3 times 2 either, right? So then when it's 3, it can't be 2, it still has to be 1, right? The only time when it can't be 6 and it can be less than 6 is if this difference is actually equal to 2, and then A3 is equal to 2, and then you times the 4, right? So otherwise it's going to be 1. Does that make sense? Okay. So can you see why it can't be 1? So my thing is, why can't these things be 1 here? Can this be 1? Can they all be 1? That makes sense what I'm saying? Why can't they all be 1? Okay, so there's some reasons why it can't be 1. Okay, so if these are all 1, right? Yeah. Let's think about what happens here. Look at B3, yeah? So remember, this difference has to be the same the whole way through, yeah? Okay, so if this is a 1, yeah, then this difference is going to be B1 times B2. So imagine if this was a 2, right? Yeah. This difference is B1 times B2, right? If this was a 3, the difference would be 2 times B1 times B2, right? That makes sense? Does that make sense? Okay. But, okay, if the difference is B1 times B2, yeah, then the difference here is also B1 times B2, right? Yeah? And the difference here is also B1 times B2. You see? Okay. But the problem is B1 times B2, right? What happens when you minus B1 times B2 from that? So if the difference is B1, B2, what do you get if you go back 1? Does that make sense? My question, Lucas? You know what my question is?
Yeah.
So if this is the... So what happens then? So if this is B1, B2, right?
Yeah.
And that's also the common difference, right?
Yes.
What's wrong with that?
What did you say?
So my question is, if B1, B2 is the common difference, yeah?
Yeah.
And all of these numbers here are 1, what goes wrong?
All those numbers are 1, then
So if all those numbers are
Wait.
1, then the common difference is B1, B2.
If the common difference is B1 and B2,
Yeah.
and those numbers are 1, if B1, B2 is negative, then
And so they're positive, yeah?
yeah,
B1, B2 is positive, yeah?
yeah, and they're also integers.
Yeah.
So either one of them has to be 0.
Yeah, so what's B1, B2 minus B1, B2?
Something minus itself should always be 0.
Something minus itself is always 0, right?
Yeah,
So if this thing is the difference, then when you go back one step, it's going to get to 0, right?
yeah,
Yeah?
yeah,
But that's not allowed, right?
yes,
So the
yeah,
problem with having B1, B2 there like that is that there's not enough room to go back, right?
yeah,
Understand?
yeah,
So therefore it can't all be 1, right?
yes.
Okay, so what can they be? They can be, well, can it be 2, right?
Yeah,
Can it be 2? So if these are all 2, yeah, that makes sense.
yeah, it makes sense.
And then this one, like let's say this one is 3, right? Yeah. Then what's the common difference?
The common difference.
Yeah. You understand what I'm saying?
Yeah,
So the common difference here is B1, B2 again, right?
yeah,
See?
right.
Okay. And then what's wrong with that? What's wrong with the common difference between B1, B2? You understand? I feel like people are not really understanding from the previous thing. If the common difference is B1, B2, yeah? Then all of these differences are B1, B2, yes? Do you understand? Okay. And I'm saying A3 is equal to 2, yeah? So what goes wrong here?
3 equals 3.
What?
B3 equals 3.
Okay, what's wrong with B3 equals 3?
They should all be the same number if the difference is B1, B2.
No. It's if the difference is B1, B2, then B3 equals 3, yeah?
Okay.
It needs to be one more than A3 for it to be B1, B2, yeah?
Okay.
So what goes wrong with this picture, okay? I'll give you 2 minutes to think about it. Anyone see it? What goes wrong? I mean, it's the same idea as before. You just got to be paying attention to what happened before. So look, if the common difference is B1, B2, right? Yeah?
Yeah.
And this thing is 2 times B1, B2, right? Yeah?
Okay. Yeah.
What happens if you go up 1? What would you get?
Then
If this thing is 2 times B1, B2, right? And you
yeah.
go back by B1, B2, yeah? What do you get? Like B1, B2, like it could be anything. It could be like 6. If it's 2 times 6 and you go back by 6, what do you get?
0.
No.
6.
Yeah, like if you have 2 lots of 6 and you go back by 6, you have 1 lots of 6, right? This is
Oh,
some
it's still
super basic
6.
stuff. Does that make sense?
Yeah.
But then what can you do from here? So you got 2 lots of something and you go back by 1 lots of it, then you get 1 lots of that something, right?
Yeah.
Yes? And then what do you do? If you go forward, you get 3 lots of that something, right?
Yeah.
Okay. Well, what other destinations are there?
你要去布里斯班啊？不去啊，我只是随便问一下呀。他们上次跟我讲，我们上次去年也没去，去年在悉尼，这不是一定要去的了，这只是一个 information，不是一个。
Okay, so guys, look at this. If this is 2 lots of B1, B2, right? If you go up by 1, right? Hello? Focus, sit up straight. Do you understand what I'm saying? Sit down, over here. So, it doesn't even have to be B1, B2, okay? What we have, okay, is we have 4 numbers, right? Let's call this number D, yeah? Okay? So this number is 2 times D, okay? And we know the difference is just D, yeah? So if we go up 1, we get 1 times D, right? Yes? If we go down 1, we get 3 times D, yes? Okay. But all you gotta do is to think to go up 1 more time. What do you get if you go up 1 more time? So here, you're going up 1, but you can go up 1 more time. What do you get if you go up 1 more time?
0D.
0, right? Why is it so difficult? Understand? There's
Yeah.
2D, 1D, 0D, yeah? Well, here it's B1 times B2 times 2, right?
Yeah.
You go up 1, B1, B2, then it's only 1 times B1, B2, right? But if you go up again, you get 0 B1, B2, yeah?
Yeah.
So what's wrong with it being 0? 0D is just 0, right?
Yeah.
What's wrong with it being 0?
0 is it positive?
Yeah, positive numbers can't times to 0. Do you understand?
Yeah.
So that's not allowed. Yeah. So A3
Yeah.
is not allowed to be 1 or 2. Yeah. So can you see
Yeah.
that means A3 has to be at least 3. Yeah. Yes.
Yes.
Does that make sense? And these differences have to be at least 2, right? Yeah. So that
Yeah.
means the difference has to be at least 6. Because you have to times 2 by 3. You see that?
Yeah.
Does that make sense or not?
It does make sense.
Okay, so we can actually do something when we do 4, yeah? We can actually make the numbers. Okay, can you tell me what this gives us if we make the numbers 1, 2, 3, 4 and 2, 3, 4, 5? What are numbers? What are the numbers? Can you tell me?
Just B is just 1 above A.
Yeah.
A is 1, B is 2.
So A1 is 1, B1 is 2, yeah?
Yeah. And
And
they
so what
both
number do I
increase
write?
by
What do I
1.
write in here? So these are the A1, A2, A3, A4. Yeah, this is B1, B2, B3, B4. Yeah.
Yeah.
What do I write?
And next is 2, 2, 3, 4.
Yeah, 2, 2, 3, 4. Yeah. And then
Yeah.
what?
2, 3,
2, 3, 3, 4.
and 2, 3, 4.
Yeah, exactly. Yeah.
Yeah.
What do these numbers give me?
B.
Huh? What do these numbers give me?
24,
So this is 24. Yeah.
48,
D2.
72,
72.
96.
6. Yeah.
120,
20.
20. Yeah. And what does that give you? The difference is.
24.
So can you see all the differences of 24, right? Okay.
Yeah.
So so now we want to come up with an argument for why the difference can't be less than 24. Yeah. But it's really, if you're doing this by yourself, you probably don't have enough information to really try and do that. But I'm telling you to try and do that. Yeah. So this
Yeah.
is like it's a little bit of a different exercise now. But so if you have A1, A2, A3, A4, yeah,
Yeah.
and then B1,
可以吃多少？
A2,
没
A4.
有完全吃好，我可以过。你看我的手相，我是会这样。
B1, yeah?
Yeah.
Can we prove that the difference here is always
你的那个空气炸锅旁边是
at least 24, yeah? Understand? So this is really just testing if you understood what we were doing before. So once again, I also don't discourage trying every case separately, but I guess we don't currently have the time for that. But if you want to see us try all the different cases, I have a video on that, okay? But at the moment, I just want you to understand what we did before and see if you can try to replicate the argument, yeah? Okay, so I'm kind of waiting. So can you see? Can someone tell me what this is?
That's 3 case
Why is it the 3 case?
because it starts like the start is just A1, A2, A3, right? And A1.
Yeah, the letters are the same, but the thing you really got to show is that the differences are the same, okay? The reason the differences are the same is we're assuming these differences are the same, right? And then we're dividing all the differences by A4, yes? So then if you divide the same difference by the same number, you get the same difference, yeah? You get the same answer. That makes sense? So this is literally the 3 case. Does that make sense? Yeah? So the difference between the 3 case, okay? Stupid thing. The difference between these things in the 3 case is at least 6, right? Yes? That makes sense?
Yeah.
So if we can show the A4 has to be at least, if we can show these A4s have to be at least 4, right? Yeah? Then we get a difference of 24, at least 24. Does that make sense? You understand what I'm saying? So what if there were less than 4? What if all these differences here were 3? Yeah? What happens if there were 3? I mean, there could be less than 3 as well, but what happens if there were 3? You guys have no idea what we did before, huh? Hello, come on. Focus. If all those things were 3, what happens? So the smallest this thing can be is 4, you see that? So let's say that's 4, yeah? So what happens if that's 4? So let's say this is 4. Okay, so if this is 4, what is this difference? Yeah, the difference between 3 and 4 is 1, but what's the whole difference? You know these things are being times together.
It's just differences B1, B2, and B3.
Yeah? And what does that say for all the differences?
These are all differences are all B1.
Yeah, because it's called the common difference, right? It's the same, yeah? So this is B1, B2, B3, this is B1, B2, B3, and this is B1, B2, B3, you understand? Does that make sense? Yeah? Okay, now what do we do? You understand what to do from here? Like, what's the value of this number here? What is that equal to? Hmm? It's 3 times B1 times B3, right? Yes? So it's 3 lots of B1, B2, B3, yeah?
Yeah.
Okay, what happens if I go back to here? What's the value of this number here?
Oh, then that's just 2 B1, B2, B3.
Exactly, you count back by B1, B2, B3, that's 2 B1, B2, B3, yeah? And then what do you do?
And like go back another one. That's just B1, B2, B3.
Yeah, if you go back to here, that's just B1, B2, B3, right?
And you go back another, that's 0.
And you go back another one, that's 0, right? So what does that say? Lucas, what does that say?
What?
So what's the problem now? So if you count backwards from 3, B1, B2, B3, you get to 0, right?
Yes.
Yeah? What's
Yeah.
wrong with that? Can it be 0? Is it allowed to be 0?
Okay.
Why not? Why can't it be 0? Can someone tell me why it can't be 0?
Because 0 is not a perfect number.
So 0 is not the product of positive integers, okay? If you take a bunch of positive integers and you times them together, you can't get 0, you understand? You need to times things by 0 to get 0. Yeah? Unless you're in like modular arithmetic land, which we're not in, yeah? No, you don't qualify for that question. You didn't respond to any of the question I asked. So therefore, this can't be 3, right? Yeah? It can't be even less than 3, because less than 3 it'll get to 0 faster, right?
Yes.
You understand?
Yes.
So it has to be at least 4.
Yes.
Yeah? So if that has to be at least 4, and this has to be at least 6, then when you times it together, you get at least 24. You understand?
Yes, I understand.
Okay, I'm gonna do it one more time to see if you really understand, okay? So let's do this. So we're gonna do 5 numbers now, okay?
Okay, 5.
So it's A1, A2, A3,
and
A4, A5.
And
B1,
B2, B3, B4, B5. Yeah.
Okay, so if we do the same thing we did before, if we do 1, 2, 3, 4, 5, what was the same thing we've been doing? What's the bottom row?
2, 3, 4, 5, 6.
5, 6, yeah?
Yes.
And then what are the numbers in between?
Numbers is 2, 3, 2, 2, 3, 4, 5, 2, 3, 3, 4, 5, 2, 3, 4, 4, 5, 2, 3, 4, 5.
Yeah? And what are they times to?
They are times 2.
What are they times to?
120.
Huh? The first one's 120. Yeah?
Second one is 240.
Yeah. And you see the second one's just 2 times the first one, right?
360.
360. So the third one is just 3 times the first one, right?
480. 600. 720.
Yeah. So what's the difference?
420.
420. What?
Oh, you're just timing the
120.
numbers together.
Yeah.
So this multiple is from 1 times 2 times 3 times 4 times 5 is 120.
Yeah, exactly.
And 2 times 2 times 3 times 4 times 5 is 240.
Yeah, it's 2 times. So this is what you might call 5 factorial, right? And this is 2 times 5 factorial. This is 3 times 5 factorial, yeah?
Yes.
This is 4 times 5. So basically you're counting by 5 factorial, yeah? Get it?
Yeah.
Okay, and we want to now prove it can't be less than 5 factorial, you understand? So remember the answer we got for the last case was 24. 24 is 4 factorial, yes? Now we want to show it can't be less than 5 factorial, you understand? How do we show that?
Can't be less than 5.
And I'm actually telling you, it's the same way we did it before, you just have to understand what we did before, yeah?
Oh, okay. Yeah. Because 5 factorial is because of like A1, A2, A3, A4, A5. Is counting out? Question mark?
Come on guys, I want an argument.
If we have like A1, A2, A3, A4, and A5, and then we know the other row is like 4, 4, 4, 4, and then the last row is 5.
Mm-hmm.
So then do the same thing. The last row is just 5 times B1, B2, B3.
Okay, so look at this, yeah, that's what you're saying. Right?
Yes.
And this has to have this also a common difference This also has to satisfy the n equals 4 thing because it's the n equals 5 thing is the same difference and they're all divided by the same number a5, yeah? Okay. And then what are you saying?
And we can like assume that A5, all the fives are like 4.
Yeah, so we want to show a5 is greater than or equal to 5, yeah? Because all these differences are at least 4 factorial. Okay, if a5 is greater than or equal to 5, then the answer is going to be greater than or equal to 5 factorial, right? So if it's not bigger than 5, like, let's see what happens if it's 4, yeah? So if these are all 4s, yeah? Then what happens?
Then since like the corner right one, it has to be 5.
Okay, it doesn't have to be 5, but if it's bigger than 5, the difference will be even bigger. Does that make sense?
No.
So this 5 makes the difference the smallest. Yeah? And what is the difference?
Well, the difference is B1, B2, B3, B4 because four is just 4 times B1, B2, B3, B4, and 5 is just like
Yeah.
6.
And then this number has to be bigger, but it could be 6 or 7. But if it's 7, then it'll be just 3 times this. You understand? So this is the smallest difference we can get, yeah? We can get bigger differences as well. Does that make sense?
And that means this is 4, B1, B2, B3, B4.
Yeah.
And the next one is 3 times that.
Yeah, that'll be
The next
3.
one is 2 times that.
That'll be 2.
And the next one is 1 times that.
That'll be 1.
And the top one is 0.
The top one will be 0, right?
And 0 again is not a positive integer.
Yeah. So, can you see, this could be like 8. What happens if this is 8? You see? What happens if this is 8?
If this is 8, then the difference would be 4, B2, B3, B4.
Yeah, it'd be 4, right?
And the next one would be 0.
The next one's already going to be 0, yeah?
Yeah.
Because the point is the difference is bigger. It's going to get to 0 sooner, right? Like it might not even get to 0. It might just go negative straight away, yeah? Yeah?
Yeah.
But 0 or negative is not allowed, right? Because they're positive numbers timesing together. Yeah?
Yeah.
Does that make sense?
Have negative, because it has to be positive.
Yeah, so what this idea is, it's basically, it's kind of the most natural way to continue from the small cases, okay? It's called mathematical induction. Does that make sense? So what you're doing is you're using the previous case to get the next case, yeah? And if you can do it in general, then you can get to any case you want by just counting. Does that make sense? Do you understand what I'm saying?
Yes.
Okay, I might make another summary of this in general and see if you can understand what I'm saying, okay? But you seem to understand this now, right? Yeah? So the way mathematical induction works is you show the smallest cases true, right? And you show that going up by 1 is always true, yeah? Then you can get up to any number you want. Because you can always get up to any number you want by just going up by 1 over and over again. Does that make sense? Okay. Alright. Lucas, you understand this? Is Lucas still here?
Yeah, what's up?
You understand?
Yes?
Alright. Okay, I'm gonna make a video for the general version if you see if you understand the general version, okay?